This problem will be related to our density of pennies lab, where I happen to have a coin that is made of two elements. This is not an alloy, which means that the two elements are not melted all together. We can use this math when we have an example of like an object like a coin that has a core of one element and then it's layered. The other element is layered around it. That's the only way this math actually will work. So let's assume in this problem we have like a coin that has maybe a gold core and then it's layered silver around it. And I want to figure out what percent of this coin is silver and what percent is gold. So this is kind of another example of kind of like what you did in your penny lab. Some important information is I'm going to give you the density of silver and I'm going to give you the density of gold, which you can see right over here. Here's the density of silver and the density of gold. And I'm also going to give you the density of a coin. One of these coins has a density of 12.00 grams per milliliter. Now, what we can do is some common sense right away. We can make a pretty good guess that this coin is mostly silver or mostly gold. What do you think? Well, 12 is a lot closer to 9.32 than it is to 19.30. So I'm going to assume that the largest percent of this coin is going to be silver. And I want to figure out how to figure out what the percentages are. So these are kind of complicated algebra problems because we have two unknowns. We have the percent of the coin that's silver, and we have the percent of the coin that's gold. And when you have two unknowns, what you need is two equations to be able to solve for these two unknowns. So I'm going to, at the risk of you not remembering what the symbols for silver and gold are, I'm going to the symbols for silver and gold are Ag and Au from their Latin terms. But what I'm going to do is I'm going to say let's let S let S be the percent of the coin that is silver, and let's let G be the percent of the coin that is gold. So S and G are not the element symbols for these, but I'm going to use these as variables. Instead of X and Y like we did in the penny lab, I'm going to use S and G so we can kind of keep track as we go through. So the two equations we need, the easier one, if you remember, is if I take S plus G, the percent of the coin that's silver plus the percent of the coin that's gold, and we're going to keep these percentages in decimal form, remember. We know that they have to add up to 100%. That if we're keeping them in decimal form, that means they have to add up to 1. We only have two elements here, and so the percentages need to add up to 100%. Or in decimal form, they need to add up to 1. So that's our first equation that we can use. Our second equation is the more complicated one. It's how you calculate your grade in a class or something. I'm going to take the percentage of the coin that's silver times the density of silver. So I'm going to take 9.32 times S plus the density of gold, 19.30, times the percentage of the coin that is gold, which is G. And that should actually give me the density of the coin. That should give me the density of the coin. If I take the percentage of each of those densities and add them together, that's going to actually give me the density of the coin. So these are my two equations, and I need to solve for one variable and then sub in for the other one. The easiest one to do that for is over here. I can say S equals 1 minus G, and then I can sub this S in for there when I do some math. So I would have 9.32 times quantity 1 minus G plus 19.30 G equals 12.00. And I can just do algebra from this point on. You'll see I only have one unknown in there, G, so I'll end up solving for the percentage of the coin that is gold. And I can distribute the 9.32, so I would get 9.32 minus 9.32 G plus 19.30 G equals 12.00. I can consolidate the G's here, 19.30 G minus a 9.32 G, and that would give me a 9.98 G. Both of those went to the hundreds place, so I should still go to the hundreds place. And I could take 9.32 over to the other side, subtract it from 12, so that would be equal to, and they both go to the hundreds place also, so it would be 2.68. And then, of course, G is going to equal 2.68 divided by 9.98. And you'll see I have 3 sig figs there. Now, of course, I'm going to take this times 100 to eventually put it into a percentage. And I have 3 sig figs there, and if I do that, then it'll end up being that this coin is made of 26.9% gold. 26.9% gold. Now to find the silver, I don't have to go back and do all this math over. The percentages need to add up to 100%. So if I take 100 minus 26.9, I would get 73.1% silver. And that, of course, agrees with what we were originally thinking. The density of the coin of 12 was way closer to silver, so we assumed that a larger percentage of this coin had to be silver. And indeed, 73.1% of this coin is silver and 6.9% is gold. So hopefully you can always come back to this video and see how to do these density percent composition problems.